today's stuff. Standard position. A lot of today is going to be about, in this section, is going to be about language. Okay? So this didn't show up very well, so let me change colors and see if it looks better. Does that look a little bit better or no? Okay, so this is called the initial side, which for us in standard position, the initial side is always the positive x-axis or 0 degrees. It'd help if I had a pen. There we go. 0 degrees is always our initial side. Is everybody okay? And what does the word initial mean? The start, right? Or the beginning. So this is where we're going to start. The vertex, which is the place of hinge, is always going to be at the origin. And then what does it mean to terminate? To end or stop, right? So we call the terminal side where the angle actually stops. Yeah, or if you want to use notes. Okay, it's up to you. But the main thing here is I want to make sure that you're okay with the language, because the questions in your homework are going to ask you, draw an angle in standard position with the terminal side at this place. So you have to know what that language means. Okay? So what we do to draw the angle is, you guys said yesterday that circles can spin in which direction? Which way can you move on a circle? Do you have to move clockwise or counterclockwise? No, you can move either, right? So what you do to show the direction of rotation is you actually draw an angle, like draw an arrow, from the initial side to the terminal side, and that tells the reader which way we move. Okay? What we're saying right now is that our angle started here, and then it went up this way through the arrow until it stopped right there. Everybody okay with that? Yes, no, maybe? Versus if I wanted it to go, if I wanted the angle to go this way, I would have drawn the arrow from the initial side here to the terminal side in that area, or in that direction. So everybody okay with standard position? So your initial side is the positive x-axis, or 0 degrees. Your terminal side is wherever the angle stops. And if we have a positive angle, we move up through the first quadrant. If we have a negative angle, we will actually move down through the fourth quadrant. Everybody okay with that? Yes, no, maybe? So for us, our angles are going to start and move positive this direction, and negative is going to be down that way. I know, you guys are going to feel like you're on sensory overload for the next week or 2 or 3. Like I told you, trigonometry itself is not really that hard. What's hard about it is it's a completely different set of language. Okay? So like, if we compared it to something, those of you that have taken Spanish, right? There's a difference between colonial Spanish and Mexican Spanish, right? They're different enough. So what I'm going to ask you to do is, we've been teaching you the language of math. Now I'm going to teach you a new dialect of it. And that's basically what trigonometry is. Okay? So your brain's going to feel like there's so much coming into my head. There is. It's a slightly different set of language that we use. Okay? So that's why it's really important that you all take good notes in this. Yeah, is because you have to learn not just the math, because the math itself really isn't that hard. It's addition, subtraction, multiplication, and powers. That's it. What's hard is learning all of the background information that goes along with it. Okay? So the more you work with this stuff, the more you focus on the background and the language and what it means, the easier the actual math gets. Because then you're not, what does it even mean? I don't know what to draw. You can go, oh, I draw this. And then we can work on particulars. But if you don't know what the language means, you're stuck from the very beginning. So the decoding is the hard part. But is everybody kind of okay? Initial side is where we start. Terminal side is where we stop. Positive angles rotate up. Negative angles rotate down. Everybody all right, you think maybe possibly? All right. So let's take a look at one. Draw an angle with the given measure in standard position. So 240 degrees. If you flip your unit circle over so that it's the actual unit circle, right, that we just filled in, can somebody tell me what quadrant is 240 degrees going to be in? The third. Okay, is it really close to the x-axis? The y-axis are about in the middle. Closer to the y a little bit, but it's kind of near the middle, right? Okay, so what I'm going to do here is the first thing that I need to do is draw my initial side. So where's the initial side always going to be? The positive x-axis. So I start at the origin, and I go down my positive x. Everybody all right with that? Okay, where's the terminal side? First, second, third, or fourth? 240 is bigger than 180, right? So it's got to be in the third quadrant. So it's something like that, right? Did I measure this out with a protractor and get exactly 240 degrees? No, I want you to sketch it. That's it. Am I done yet? Not quite. I have to show the reader which way to rotate because it's a circle. We can go up or we can go down, right? Positive 240 degrees. For a positive angle, do we go up through the first quadrant or down through the fourth quadrant? We go up. So that means that we're going to start here. We're going to go up and curl through like that. That's what your angle should look like. I need to see an initial side, the vertex at the origin, the terminal side, and then you have to give the angle or the arrow to show rotation. Everybody okay? Yes, no, maybe? So that's all I need you to do. So can everybody find like about where 240 would be on your unit circle? So I just want you to get this close because the angle is positive. Positive angles always rotate up into the first. Negative angles will always go down into the fourth. So yeah, if you look at your unit circle, right, this was 0, and then when I went up, was that a positive 30 or a negative 30? So my positives go up through the first, second, third, and fourth quadrant. And then negative angles just mean that we move the same distance but in the opposite direction. So we'll go 4, 3, 2, 1. Okay, 500 degrees. Is 500 degrees on your unit circle? No, because how many degrees in a circle? 360. This is bigger than that, right? So what I'm going to do is take the 500 and subtract 360, right? Because 500 just means that I made more than one rotation, right? I made one full rotation, then I got some left. So what's 500 minus 360? 140. So where's 140? First, second, third, or fourth quadrant? The second. So I'm going to have my angle somewhere over here. 140 is going to be like that-ish, right? Now for my rotation, if I go here and stop here, is that at 500 degrees? No. So if I make one full rotation, I have to have my arrow make one full rotation. Everybody all right? So what I do to show the reader what's happening is I start on my initial side. I curl up in the positive direction. That's 360 degrees. And then I have to go another 140 like that. So it shows the reader we made one full rotation all the way through our circle, and then I went to stop. Everybody all right with that? You think yes, no, maybe? Okay, what about negative 50? So negative degrees, do they go up or down? They go down, right? So is negative 50, do you think that's going to be in the first, second, third, or fourth? Fourth. So negative 50 degrees is mathematically the same thing as 310 degrees, right? 310 is moving from the positive side, negative 50 from the negative side. Everybody good? So did I move in a positive or a negative direction? Negative. So do I curl up through the first or down through the fourth? Down through the fourth. Okay, so negative angles go down, positive angles go up. Everybody okay with that? You think maybe, possibly, I don't know, I might be willing to give it a shot on homework? Okay. Again, yeah, what you're going to learn is a lot of the math isn't hard, but it's extremely particular, and it's language you haven't really seen before. So, coterminal angles. What does it mean to, what does the word co mean? Okay, it's in a group of something. So, like, if you're a co-worker, right, it's somebody that you work with. So, it means that you do the same thing with them. So, what do you think the word coterminate means? Right, they both stop, right? So, I've got my blue angle here. Is that a positive or a negative angle the way I drew it? Is this a positive or a negative? It's a positive. But what if I were to go the same distance, or sorry, to the same place, but in the opposite direction? Is that a positive or a negative? A negative. So just like I said, if we went negative 50 degrees, right, I could go 310 degrees and get to the exact same spot. And it would be the same values, right? It would be the same spot on the circle. Yes. Yeah, negative goes down, positive goes up. What the word coterminal means is that they both stop on the exact same spot of the circle. So it doesn't matter if you're making 5 rotations and then going there, or if you're just doing 1 rotation and going there. It matters where it stops. Yeah, we wanted to start and stop in the same place, but you can do that by going positive, negative, or doing multiple rotations. Okay, so there's an infinite number of angles that we'll get right here. Because it's a circle, it never stops, right? So coterminal just means that they stop in the same spot. So what we're going to look at is find a positive and a negative angle that are coterminal with the angle given. So the first one here, that's kind of small. If I said that theta is equal to negative 45 degrees, okay, is that positive or negative? Negative. So if I drew it out real quick, it would be like that, right? This is negative 45. Okay, so if I wanted a positive angle that's coterminal with it, I'm going to start at my 0 still, but which way am I going to move, up or down? Up. So I want to go all the way over to here. So how many degrees is it to go from here all the way around to here? So how many degrees to go all the way around the circle? 360. So what's 360 minus 45? So is 315 degrees going to get me to the exact same spot as the negative 45 would? Yeah. Everybody okay with that? So like if we go back to your unit circle, I want negative 45 degrees. So 360 minus 45 is 315. And this distance here is negative 45 degrees, which you said makes sense because this is in the same spot as this. Everybody okay with that? Yeah? So the negative 45 gets us 315, and that's a positive angle, right? What if I wanted another negative? How can I get back to negative 45? Okay, do one full circle around and then go how far? Okay, 45 degrees. So do I want to move, for that one though, do I want to move in the positive direction, or the negative direction? Negative. So I'm going to take negative 360 plus negative 45, and what am I going to get? What's negative 360 plus a negative 45? Negative 405. So 315, negative 405. Now, those of you that have calculators, I want you to get them out real quick. I want you to see something what this really means. Okay, so on your calculators, tell me, what is the sign of negative 45? .7 what? So what's the sign of 315? What's the sign of negative 405? Does that make sense or no? Okay, why? All right, so these three angles are all actually the exact same place on the circle, right? So if the trig is related to the circle, and they're all stopping in the exact same spot, then they're going to get you the exact same answers. That's why using coterminal makes sense. Some of you don't like using negative angles, so you'll be able to convert them over to positives and type them in and get the exact same answers. Everybody okay with that? Yes, no? So that's the connection that we're looking for up here, okay? So what about 395? What quadrant is this in right now? It'll be in the first, right? So how many, so it's actually one full rotation plus a 35-degree angle, right? Everybody okay with that? So we're going one full rotation plus a 35-degree to get to my 395. So if you look over here, what did I really do? I took the angle they gave me of negative 45, and what did I add to it? 360. So let me do that again. If I take 395 and add 360, am I going to get a positive or a negative angle? Right. So what's 395 plus 360? 755 degrees, right? What did I do here? I took them at negative 45, and what did I do to it? Subtracted 360. So let me take 395, subtract 360, and what do I get? 35. Okay, do I have one positive and one negative here? I have two positives, right? So either of these would work. But if I know that it's 35 degrees in the first quadrant, what can I do with the 35 to get back there? If I'm here, can I take away another full rotation and get right back? Yeah, so I'm going to take the 35, subtract another 360, and get negative 325. So all we're doing is we're either adding 360s or we're subtracting 360s, because remember, how many degrees in a rotation? 360. So I'm basically adding rotations or subtracting rotations, which I guarantee will get me right back to the same spot. Is everybody kind of okay with what's going on? And again, it's a different way of thinking because everything is on a circle. Okay, it's just kind of like when you start playing with parallel lines, right? If I told you that every line is parallel, you have to change the way you look at things. For us, everything we're going to be doing is going to be on a circle. We're making angles which all come from circles. So we can do infinite rotations in either direction. Everybody all right? You think so far? I said if I were to do that, yeah. There's a type of math where that actually happens.